Beltran, and this is CNN. Today's segment is a science special which celebrates the International Ideal Gas Day. First, we'll review the laws. An ideal gas is a hypothetical gas that perfectly fits all assumptions of the kinetic molecular theory. A real gas will behave as an ideal gas if the temperature increases or if the pressure decreases. These laws describe the properties of gases and the relationship between temperature, pressure, volume, and number of moles. Boyle's law states that the pressure and volume of a given mass of a confined gas are inversely proportional if the temperature remains unchanged within a closed system. Charles's law states that at a constant pressure and constant number of particles, the volume of a gas increases or decreases by the same factor as temperature in absolute temperature scale. Gay-Lussac's law states that at a constant volume and number of particles, pressure increases or decreases by the same factor as temperature in the absolute temperature scale. Avogadro's law states that equal volume of gases at the same temperature and pressure contain the same number of molecules regardless of chemical nature and physical properties. The combined gas law is a gas law which combines Charles' law, Boyle's law, and Gay-Lussac's law. There is no official founder for this law. What this law is a combination of the three main gas laws. The ideal gas law states that the pressure and volume of a gas have an inverse relationship when temperature is constant, and the temperature of a gas has a direct relationship to both pressure and volume when either one is constant. The relationships described by the ideal gas law are represented by the equation PV equals nRT. Graham's law states that the rates of diffusion of gases at the same temperature and pressure are inversely proportional to the square roots of their molar masses. Dalton's law states that the total pressure of a gas mixture is the sum of its partial pressures. On the field, we have special reporter Katia Doherty with a student who attends the American School of Guatemala and is today with us, presenting her Boyle's Law experiment.
Good afternoon. Today I'm at the American School of Guatemala's chemistry laboratory with one of their own students, Katina Uribe, who's going to present her Boyle's Law experiment.
The materials I used were 2 balloons, a plastic water bottle, a pair of scissors, and a meter. You have to cut the plastic bottle at the bottom. The second step is you get rid of the bottom and you put the first balloon in through the mouth of the bottle. You try to put the mouth of the balloon around the mouth of the bottle. Like this. Then you cut the balloon at its mouth. After you cut the balloon, you grab the larger piece and you put it at the bottom of the bottle, like this. Now it's time to start your experiment, but first make sure that no air is coming in from the bottom of the bottle. First grab the bottom of the balloon and pull it downward, and you'll see that the balloon inside starts to inflate. This is due because the pressure of the bottle decreases as you pull downward and the volume of the balloon inside increases. My experiment results were supported by the kinetic molecular theory. As pressure decreased, volume increased because the molecules are farther apart. Molecules decrease the frequency of collisions with each other and with the container walls. My hypothesis was supported, just as Boyle said. As pressure decreases, the volume of the balloon increases.
That is all for this week. We hope you enjoyed this week's special and learned plenty about the gas laws. For next week's special, tune in.